Okay, I don't want to refer to the section or question number because this is kind of a classic type of calculus problem, but I don't want to refer to exactly where it's from. So anyway, you know which problem I'm talking about, and I'm going to call it the crazy circle sector area problem. And first of all, let me just give a little background. So if you have a circle, we know that the area of a circle is pi r squared, right? And what else do we know? Well, if the whole circle is pi r squared, then what is this area going to be? Okay, so the whole area is equal to pi r squared. Okay, and the shaded area has to be some ratio of the whole circle. So it's theta over 2 pi times pi r squared. These guys cancel out and you get r squared theta over 2. Okay, so that's really how you do the problem. Now, why would anybody go about doing it any other way? It would be completely nuts. That's why it's called crazy, right? So the crazy way is to say, well, this circle, you know, goes through the origin, and it's x squared plus y squared equals r squared, and you solve for y. All right, so this is the top half of the circle. And then what you want to do is you want to just integrate this guy from and get this black shaded area, and you add in this other shaded area. So maybe I'm going to call this like the red shaded area, and this is maybe the blue shaded area. Okay, something like that. There we go. Okay, so we've got the reds and we've got the blues. Okay, and if we add those together, that should equal, so red plus blue, we hope, is equal to r squared theta over 2, right? And it will be, okay? So it turns out the red stuff is easy to figure out. Well, what's going on? Okay, if this is r, okay, so from here to here is r cosine theta. So that means this point, this x value is r cosine theta, and that x value is r. Remember, cosine theta has to be less than 1 or equal to 1. So this should all work out. Okay, so what's going to end up happening is, okay, this part here is our sine theta. So the red area, which is area 1, is equal to 1/2 base times height. So r squared sine theta cosine theta over 2. So that's the first area. Okay? Now the hard part is the blue stuff, and the blue stuff is area 2, and that's just going to be the integral from r cosine theta to r of this mess. Da-da, no big deal. And what's going to end up happening is this whole expression is going to come with a negative sign attached. It will cancel, and the term we really want will end up being in the mess too, and that will percolate out and be the answer we're looking for. So that's the game plan. And so there's a lot of details in this question, and so let's go ahead and start working on that. All right. Right, so here's a problem, and so let's figure out what we can do. So we know this chapter that this problem came from was a trig subs question, and so there's a little thing in the book that says, well, when you see this type of situation, you simply say let x equal r sine theta or cosine theta, but I'm saying let's not do theta because we've already got a theta in the problem. Let's make it sine t. Okay, so it could be sine t or cosine t, it doesn't matter, it'll work out exactly the same way. Okay, Then you do a whole bunch of messing around. So for example, you have to figure out, you have to solve for t. T is an angle whose sine is x over r. Okay, we also have to know x squared is r squared sine squared t, and r squared minus x squared. I mean, this is the whole reason we picked x is equal to r sine t, is so that this particular stunt would work. Because you look at this mess and you see, sine squared plus cosine squared is 1, so if it's 1 minus sine squared, it's cosine squared, or 1 minus cosine squared is sine squared. And so we're just doing this to make it work. Okay, and then we're going to take the square root of that, and then you get r cosine t. All right, so now let's put all these pieces together. And so, first of all, angle whose sine is x over r. So, what are we going to do? We're going to say t is angle whose sine is x. Well, x is r. So I'm going to write it this way just to drive the point home. And down below, angle whose sine is r cosine theta over r. The r's cancel, and the r's cancel here too, right? And I'll come back to that in a second, but I'm going to put all these pieces together first. This guy. And what else did we have? Let's see. We needed dx. Dx is equal to r cosine t dt. But we already have r cosine, so we have another one now, and then where we go? There we go. R squared can go outside, and so far so good. All right, so let's, moving right along here, let's see what we can do with this problem. What is an angle whose sine is 1? An angle whose sine is 1, well, if you think about this, angle whose sine is 1, that happens at pi over 2. So you just say, all right, that was pi over 2. No big deal. And then what about angle whose sine is cosine? Well, this you got to just remember what that's really saying. Okay, so remember, whatever this is theta, all right, if this is sine theta and this is cosine theta, but then there's another angle on the other side of the triangle, and that is, say, cosine of phi, sine of phi. And the point is that phi plus theta have to equal 180 degrees or pi, right? All right. Pi over 2. Right? Because we have, right, so the point is 180 degrees in a triangle, or pi is equal to this guy, which is pi over 2, plus the other pi over 2, which is these angles over here. Okay? So that's what it means to be complementary angles. So what we're saying is angle whose sine is cosine of theta. That whole thing just means pi over 2 minus theta. Okay, so that wasn't as hard as it looked. Just erase all this mess. So now it looks very, very easy, but there's still a little bit of mess there. And we just look up in the book, or remember, cosine squared of t can be written as 1 plus cosine of 2t over 2, and this is a standard substitution we make whenever we're trying to integrate cosine squared. So that shouldn't be too surprising. But again, this is just, that's in the book, and that's something that's definitely fair game for homework. Whether or not I'd expect you to recall it during an exam, maybe it's on your crib sheet, maybe it's not, but you definitely can do that for homework. Okay, now what? Well, I'm going to just take the divide by 2 outside the integral. Okay, it can wait out there. All right, now what? Well, this splits up nicely into 2 integrals, the first of which gives us our promised good stuff. Okay, so let's just split this up into two integrals first of all. This is just going to be r squared theta over 2. Oops, I'm sorry, this is supposed to be a t at this point. It will very soon turn into a theta though. Okay, and now this piece is going to be r squared pi over 2 minus this whole stuff on the bottom. So minus a minus is a plus. These guys cancel. You get r squared theta over 2, which is actually going to be our final answer. Okay, because remember that stuff way at the top, this mess we need to cancel out with something. Okay, so that stuff is going to end up canceling with this stuff that we're going to do next. Okay, so I'm going to go ahead and erase all this, and now I'm going to do the other half of the integral. All right, so the other half of the integral is going to look like this: cosine of 2t, pi over 2 up here, pi over 2 minus theta down here. So that's the mess we're talking about. There we go, trying to look at this. Okay, so what's going on here? Well, here's something you need to think about. First of all, well, let's go ahead and integrate it because it hurts nothing. Okay, let's go ahead and integrate. Okay, we're going to integrate this, and we get sine of 2t, but divide by 2 because we're integrating, and we get these little limits like we had before. All right, now the first piece we get is really easy, sine of 2t, and then minus sine, he's okay, 2 times this mess over 2. Okay, so what is sine of pi? Theodore, can you say 0? 0? Sine of theta is 0, right? Okay, so this piece goes away. Great. And this is a minus sign, which we're really happy about right there because we're hoping that we can get rid of this mess up above. That's what we're hoping for. So it's looking promising. We've got our r squared over 2 and our minus sign, and so we're almost good to go. What we have at this point is we have minus r squared over 2, but then we have sine of 2 mess over 2. Okay. Let's make this a little slightly bit nicer. Distribute that 2 on the outside. There we go. And now it's going to just be a little ways till the end. We're almost there. All right. So let me ask you a question. Sine of x looks like this. This is one period of sine of x. Start at 0 and you work your way up. What does sine of pi minus x look like? Well, sine of pi minus x also starts at 0 and works its way up. The sine of pi over x, see, the period is the same because there's no multiplier in front of that x there. So the speed of this thing is the same. It's just going in the opposite direction, and you're starting at pi. So it has to actually be the same as sine of x. Okay, instead of memorizing crazy formulas, you figure these things out by just looking at the graph and figuring out, well, where's our starting point, which way you're going, and so on and so forth. And then that saves your brain a lot of memory power because you don't have to figure that out. If you prefer to use, the sine a plus b formula to figure that out, you can use that too. Sine of a plus b is what? Sine of a cosine b plus sine of b cosine a, and then you can work out all the pieces and find out by that mechanism that this is also true. Okay, or you can just look it up. Okay, so that all being true, okay, then it means, if that's true, then sine of pi minus 2 theta is equal to sine of, in fact, 2 theta. Well, but what is sine of 2 theta? We happen to know that that is 2 sine theta cosine theta, and we are really happy because we are done, because this is equal to 2 sine of theta cosine theta. The 2's cancel. This whole mess now cancels with this mess, and we end up with the red plus the blue equals r squared theta over 2 as promised.
What?
Say bye-bye.
Bye-bye.